Hello everyone, welcome to our channel Mathematics Pathshala. This is a problem of CSIR NET June 2024 Mathematical Sciences. This is a problem of real analysis part B. The question ID is 704040. First we read this question. Let S be a dense subset of R and F such that R to R be a given function. Define G such that S to R by Gx equal to Fx, that is G coincide with F on S and S is a dense subset of R. Which of the following statements is necessarily true? So we have to examine the options one by one. Option 1 says that if F is continuous on the set S, then F is continuous on the set R minus S. Option 2 says that if G is continuous, then F is continuous on the set S. Option 3 says that if G is identically 0 and F is continuous on the set R minus S, then F is identically 0. Option 4 says that if G is identically 0 and F is continuous on the set S, then F is identically 0. So one by one we will discuss about these options. So first look at option 1. First let me write the what is given in this question, the hypothesis, that is given S is dense set, that is S bar equal to R, and we are given also G equal to F on S. These two things are given in the question. Now look at option 1. Option 1 says that if F is continuous on the set S, then F is continuous on the set R minus S. So for this, if we take simply S equal to the set of all irrational numbers and define F by R to R by, in this way, a very common function Fx equal to 0 if x does not belong to Q, and if x belongs to Q, that is of the form m by n, then Fx equal to 1 by n. This is a very well known function, and we know that this function is continuous at all irrational points and discontinuous at all rational points. Let me write this. F is continuous at all x belongs to I and discontinuous at all x belongs to Q. Now see option 1. This S equal to the set of all irrationals, and clearly if is continuous at all x belongs to I, that is S. So the given hypothesis satisfied, and then it says that if is continuous on the set R minus S. Here R minus S equal to Q, and if is not continuous on R minus S. So option 1 is not the correct option. Now also look at option 4. If we just take this same function and the same set S, then see G is identically 0. Here Gx equal to Fx when x belongs to Q, and at x belongs to Q F is 0. So we have Gx equal to 0 for all x belongs to Q. So here G is identically 0, and also F is continuous on the set S as F is continuous on I. So also for option 4 the given hypotheses are satisfied, that is G is identically 0 and F is continuous on S. Now see, it says that then F is identically 0, but here F is not identically 0. So option 4 is also not the correct option. Now look at option 2. If G is continuous, then if is continuous on the set S. For 3, this is also, for 2, this is also not the correct option. And for this, we have to take this type of example. Fx equal to x when x belongs to q, 0 when x does not belong to q, and we take s equal to q. Now we know that this function is continuous only at x equal to 0 and discontinuous at all other points. Now see option 2. If G is continuous, so here what is G? Gx equal to fx at x belongs to q, and so gx equal to fx equal to x when x belongs to q, that is G's identity map on q. So any identity map is continuous, so clearly G is continuous. And then says that f is continuous on the set S, but s equal to q, and f is continuous only at x equal to 0 and discontinuous at all other points. So if is not continuous on the set S here. So this option 2 is also not the correct option. So option 3 will be the only correct option. And now we need to prove this option, that if G is identically 0 and if is continuous on R minus S, then if is identically 0. So see what we are given. We are given first in question that S is dense, that is S equal to R, and G equal to F on Q. This is we are given in question. And what we are given in option 3, that G is identically 0. This is we are given. And we are given that F is continuous on R minus S. So this this we are given, and we have to prove that f is identically 0. F is from R to R. We need to prove f is identically 0. Okay, so we need to prove that f is identically 0. Now see, we are given that G is equal to f on Q and G is identically 0. So we must have f is identically 0 equal to G on Q. Sorry, not Q, this is on S. This is on S, sorry. G equal to f on S, not Q and I here. We are given any dense set S and G coincides with f on S. So on S. So we are given G equal to f and G equal to 0. So f equal to 0 on S. So this is we have. So we need to prove only f is identically 0 on R minus S. So if we can prove this, then this result will be proved. So take one arbitrary point, x belongs to R minus S. And what we are given? We are given that f is continuous. F is continuous on R minus S. So f is continuous at x, because we have taken an arbitrary point x from R minus S. So now we have f is continuous at x, and also x belongs to R minus S equal to S closure, because S closure equal to R. So as this x belongs to S closure, there exists a sequence xn contained in S such that this xn converts to x. Now see, as this f is continuous at x, by sequential criteria we have this fxn tends to fx, and as this all xn are from s, and we have f is identically 0 on s, so we must have all such values f of xn equal to 0 for all n belongs to n. So what is about this sequence, this fxn sequence? This is simply a constant sequence, all terms are 0. So this must converts to 0, and as this fxn converts to fx, so we must have this fx equal to 0. So what we get, we have taken an arbitrary point x belongs to r minus s, and we have this fx equal to 0. So we have this, as this x is taken arbitrary from r minus s, so we have fx equal to 0 for all x belongs to r minus s, and also we have fx equal to 0 for all x belongs to s. Now as f is 0 on s as well as r minus s, so we have fx equal to 0 for all x belongs to r, that is f is identically 0. So this is the statement what we have to prove, that fx equal to 0, that is f is identically 0. So now look at option 4, that we are given look at option 3. We are given g is identically 0 and f is continuous on r minus s, then f is identically 0. So this statement we now have proved. So option 3 is the correct option, and option 1 to 4 are not the correct options. This is the complete solution of this problem. Thanks for watching.